Hi, Shri.
Hey, Devon here. Manoj.
Yeah, hi Shri. Good evening.
Good evening. You guys got a chance to work on the linear regression?
Yeah, yesterday I tried.
Good. Very nice. How about you, Dev? Dev, did you get a chance?
Hello. Yes, Shri.
You understood, right? What is the need
Yeah,
of
yeah,
linear regression? Okay.
yeah, yeah.
So today, let us move to the next one, which is called logistic regression. See, the name looks like regression only, but that is not like linear regression. And why we need to go for this and what is the importance of this logistic regression? Let us discuss, okay? Just give me a minute. I'm sharing my screen. So when I talk about linear regression, we were mainly focusing on the numerical value prediction, right? Do you agree, both of you? Why?
Yeah,
So the
Yes.
objective of linear regression is to predict a numerical continuous variable. If any time I want to predict any numerical value like house price or company sales or like a manufacturing mission downtime or any kind of numerical value, which is a continuous value, then I need to opt a regression, especially linear regression will fall as a first algorithm. But it is not like every time you go and predict numerical value, right? Sometimes you also predict the categorical data also. What is meant by categorical if in your understanding, if I ask you, both of you?
Categorical means it's a grouping of,
Can we say
right?
like yes or no? Yes is one category, no is one category.
Yeah,
True or false?
yeah.
And sometimes
All,
you create a flag variables 0 and 1, active inactive, correct, right?
mm,
To make a record as like logically I want to delete, not physically. We create a flag, right? Active, inactive record. 0
yes,
means I'll make it as inactive. 1 means active.
yeah, yeah,
So here 0 and 1. Generally, this kind of data we call it as discrete data. Discrete data means you will have a fixed value. 0, 1. This will be called as discrete. If my data is numerical, categorical, both, which means that 0 and 1. If I am predicting a value 0 or 1, then we need to go with a logistic regression here. So I can use linear regression also, but I cannot go and predict whether, assume that I got a requirement where I want to predict whether a email is a spam or not. Can I use linear regression for that? No, right? If at all I want to use numerically linear regression for to predict whether a email is a spam or not, what I need to do? I need to go and calculate some threshold, right? If my email, I need to calculate some threshold value like percentage. If my email is 90% spam, I will say I'll go and mark it as spam. Less than 90%, I'll say it is not spam. But every email may not be like 90% or 80% spam, we can calculate it. To overcome that, the linear regression has been optimized and it has been upgraded to a logistic regression. So we have a algorithm called logistic regression, which is basically on top of linear regression and which will fall under classification. So classification means here any manufacturing, for example, if we consider manufacturing domain, in the manufacturing, majorly most of the like manufacturing machines which will be continuously running to manufacture the products, they may go down anytime. But how do we identify that in advance? What if I don't identify in advance? If I ask you, assume that I am my manufacturing plant which contains so many manufacturing machines in that factory, and so many manufacturing engineers are working on that to like uh, to manufacture some products of P&G, Procter and Gamble. There are more than 100 machines are running continuously, and suddenly out of my 100 machines, 20 machines went down. What will happen if I ask you? What is the impact on the business? Manoj,
Yeah, obviously the production become slower, right?
slower, correct, right? When the production becomes slower
Correct.
means your delivery will be delayed. Since the delivery is delayed, ultimately your business will be impacted. So what is the solution for this? If I predict which emissions will go down in advance, I can prevent this business loss, right? Yes or no?
Yeah, correct.
Maybe 1 week in advance, I'll predict, or 2 weeks in advance, or 3 days in advance. So based on the business scenario and the business demand, I want to identify out of my 100 machines, which machines may go down in the next 1 week. That is where I can use logistic regression here. What logistic regression will do, it can classify which machine will go down, whether it will go down or not. Yes, 0 or 1. 0 means it will go down, 1 means it will not. So for this, what I require, I need the right data, correct, right? Every manufacturing machine may go down because of some factors. Because every manufacturing machine will have terabytes of data which are sensors data, IoT sensors data. The data also will be captured as a time series oriented data. Every millisecond they will capture. These IoT devices which are connected to this manufacturing machines will keep on monitoring the every mission and their status, health status, and any mission will go down. Immediately they will send a notification. So they will be keep on sending the status or health of the machine for every millisecond through messages. And this is not structured data underlined. It could be in the form of semi-structured JSON format. So we need to capture that, right? And we need to perform an ETL, and we need to find out what are the challenges for a particular mission to go down, which factors may influence. Suddenly, the power failure happened, and the mission may go down. And suddenly, a product went defect, the mission may go down. Temperature went down, our temperature increased, pressure went down. So stress failure will be there. So the manufacturing machines may go down for any reason. To keep it running continuously without downtime, the unexpected failures can be prevented by identifying the root cause. So I need to go and say if it is fail, I'll say 1. Not fail, I'll say 0, for example. In the next 24 hours, I will keep on capturing the sensors readings, and I'll try to find out which machine may go down. If it is going to fail, I'll mark it as 1. All the machines which will not go down, I'll say their status as 0. So to achieve this, I need to build a logistic regression algorithm, which is called a binary classification. Why we call it as binary classification? Because I have only two classes, right? Either 0 or 1. So we can clearly understand this is a classification task because you are classifying the machines based on the failure type. 0 means will fail and 1 means will not fail. Every machine will fall into one of these categories. So every engineer should know which is sensor contributing the failure, temperature or vibration. So there are so many factors will be there. Torque. What is required here for all this domain knowledge? Correct, right? Do you agree?
Yeah, I will agree.
First of all, you should know what is a failure, how it will happen, what factors it will going to impact. If you don't understand the domain, you cannot build this. That is the first and foremost important thing is understanding the domain. Any domain, whenever you want to build this kind of applications, you need the knowledge, domain knowledge. Then only you can understand. You should behave like a business analyst. A data scientist will act as a business analyst during this particular phase. He has to understand the business problem, right? What the customer is facing, I should know that. That is why we call it as a data science problem rather than data science project. Every problem will have a solution. You are going to provide the solution. And before that, I need to identify what type of problem it is. That is what the first step, business understanding, we call it as. We have to understand the business, which means you have to understand the domain and find out which are the important terminology of this particular domain. Failure, mission failure, temperature, vibration, sensor. You should understand all this terminology. Time series data, which means time oriented. Every millisecond will capture. So what we require here, we need, because since sensor data will be in petabytes, not even terabytes, you should have a system to capture that. That is where Snowflake will play important role here. Because Snowflake is going to allow to store unlimited data also. Plus also gives the ability to run or train your ML models on top of this large amount of data also because of the data volume and the compute it is providing. The virtual warehouses will help you here. And finally, the outcome of this problem is identifying whether a particular mission will go down or not. 0 means it will go down and it will not go down if it is 1. I need to provide this list of all the machines and their status to the manufacturing engineer so that they can plan accordingly. Correct, right? So data sources, I was talking about data sources. What data sources required here? I need the sensor telemetry data, which you will call it as the vibration, in hedges, and temperature, the pressure, everything I required. All these data I required. Plus the maintenance logs also, historical records of earlier failures and their repairs and scheduled maintenance. All this information I required. Plus, I also required the mission metadata also, mission model, mission age, how old it is, because sometimes the mission will be old also will cause the issue. The location, when the last service was happened, the date. So all these details will become the sources for my ML model. My logistic regression model will have a input data of all this. We need to combine all this together and create one single data set with all the required factors. So as a data scientist, you should use Python, here to connect to the Snowflake environment and extract the data which I required from different sources and combine them and build a single data set, and then use the ML features of Snowpark and build an ML model and train it with the training data and test it with the testing data. And here we are pushing the code near to the data, not data near to the code, because we are bringing your model near to Snowflake database and their tables. That is the difference between normal traditional data science projects and Snowflake specific projects. So environment setup, which you already know, how to install Snowpark and how to install Panda, Scikit-learn, all this I already discussed about. You already might have installed Snowpark and your environment is already ready. Correct, right? Both of you?
Yeah, it is ready.
And your connection details also I discussed about this yesterday, if you remember, the linear regression.
Yes. Correct.
I need to give the correct correction details, always. Plus, you need the, since we are using Snowpark optimized warehouse, always try to create a Snowpark optimized warehouse and use that here. And then pull the data. What are the input sources we considered? Sensor data also, right? Sensor logs, maintenance sensor logs, and then the maintenance and metadata. All these already should be present. If the data is not available in the table, I will select this particular data like this. All the sensor data, logs data, I am pulling into a data frame, Snowpark data frame with name df underscore sensor. And then review the data. And we can also review. Yesterday we discussed about the describe function. What it will do? It will provide the all fundamental statistics of all numerical columns in your data set. What statistics? Number of rows, number of missing values, mean, average, median, minimum value, maximum value, standard deviation, everything you will get. That too only for the numerical columns such as vibration, temperature, all this. All these are the summary statistics which you receive. So sometimes what happens? Your data will not be balanced. What is meant by balance? Any idea? Skewness, and also the classes should be balanced. It should not be like 90%. I got the data which is 90% normal and only 1% failure is not correct, right? I should have some balanced data. If data is imbalanced, you need to balance it. Because if my 90%, 99% all missions are normal, why should I go with the solution? Correct, right? There might be occasions, but not every time all 100% all missions may not be same. So I should balance. I should always get the balanced data. So I need to also handle missing values. This is part of the feature engineering. Missing value imputation. How to go and either replace missing values or remove the columns which are not important. If any column which is part of my data and that is not important and contain missing values, remove that. Don't keep that. So vibration and temperature, both columns where null values are there, the rows we are removing them. The rows of these two columns, wherever null is there, we are removing them because we don't want the rows which contain null. The columns will be present, but only the rows which are part of null values will be removed. Maybe out of 100, assume 5 records are having null values for these two. So I'll remove them. Wherever vibration and temperature are null, those records will be removed. And apart from this, you also need to create new columns if needed. So df encoded. This is like encoding categorical data, converting. I have columns where I need to perform one hot encoding to convert each and every mission type into a numerical value. So we are changing the mission type to a like a numerical category. Numerical category we did here. So I will use the changed the column which I changed. I am going to use that going forward. DF encoded I am going to use. That is the data frame I want to use. So I am going to use the DF cleaned will be the DF encoded I am going to use. And then feature scaling. Any idea what is scaling? Why I need to go for scaling? Any guess?
I mean, bringing all the things to one common, like 0 to 1. I mean, like have, let's
Correct,
say
you're right.
temperature is 100.
True. Correct.
Yeah,
So we need to bring the data into a single scale with 0 and 1 in between the range, with all numerical values will contain the same number of digits. Correct, right? So scaling
yes,
will try to help us to optimize your query performance and results if you go and apply the scaling. We have like scaling methods like which we can normalize. So we can use min-max normalization, just code standardization. So we can apply that so that I can bring my data into a normal form. So feature scaling is also very important. Without feature scaling and with feature scaling, you can test it. It will clearly indicate the scaling will improve the performance all the time. Then I will try to divide my data into training and testing. And we have the function which is available like random split can divide my data into 80% and 20%, 0.8 and 0.2. So 0.8 which is 80% will go to train DF and 0.2 20% will go to test DF. Plus what we are trying to do, we are saving these two data frames into two different tables. Train data is one table and test data is another table. Because we are going to use these two tables while building the model. So when you are training your model, you can directly go and call that particular respective function, or we can also try to build a stored procedure to achieve this. So Snowpark, the feature will have the concept of stored procedures where I can directly create a Snowpark like a procedure with Python coding also. So I can even do that. If at all I know that I can how to write a procedure, I can write like this. So all the my SQL activities will be in single stored procedure, which will try to like load the scikit-learn is my library. In that linear model is the module. Inside that I have a function logistic regression. Here I'm importing. Importing means we are loading that. And we are also using joblib for saving the model and pandas for data preparation. So here pandas is helping us here like here two pandas is helping to convert your training data table into a pandas data frame, and then we are trying to divide it into independent and dependent variables. So independent means which variables are going to use to predict the failure level. Failure level means here 0 or 1. So vibration is one factor. Temperature rolling average is one factor, and pressure is another factor. We have three factors here which we can use and then predict the y here. Y is nothing but the feature level. So once after my data is divided into training and testing, I'm using the model, actual model. If you observe here, logistic regression, I'm just trying to create a model and then passing this x and y here. So what this fit function will do, it will try to use this historical data and try to train my like model with the data, and my model will become like stable, and then I'll try to save the model. I'm trying to save the model as model.joblib. Joblib means this is just like how to save your ML models. And anytime I want to use that saved model, I'm just loading that here. Again, joblib.dump is going to load the model which you already saved. Once my model is ready, I'm just trying to copy the model file into a stage also. So as we are pushing into a stage, my model has been saved to this particular nodal stage. So now if anytime I want to run it, I will retrieve from the stage and I will run it. So once after your stored procedure is created, it is always advisable to register the stored procedure. How to register? You need to use the sproc, and you are clearly giving the name as train maintenance mode. And which packages are required here? I need Snowpark, and then scikit-learn, and then joblib all together. And stage is also, which we already just now saved the model file. We are using the same. And this is going to create a standalone like a store procedure, and which will be used for running your model. So you are going to run the model training code, and then that will be automatically will call this particular store procedure and execute all this. How to call the store procedure? During the Snowflake SQL environment, I need to use a keyword called call. And using call, I am calling a store procedure, whereas in Python, I will simply say session.call, and then I'll clearly mention which particular like model is going to execute here. So this is what we saved, and we are using the same. And once after my model has been trained, I'm going to identify or find out the accuracy score, and we have to see how much accurate my model is, which we discussed already in the previous class. The similar way, there we were using like R square. Here we are using a accuracy score 95%, and then precision and recall are other terminologies, but important is the model accuracy score. So model accuracy score is 95%, means your model is doing very great job. And coming to like model management, this is also very important to understand, because it can be either AI model or ML model or any kind of model need to be tracked to understand like where this model is like managing. And in Snowflake environment itself, we can manage the models. We will try to give some versioning to every ML model. That versioning will go and allow you to restore anytime you missed and you accidentally updated. You can restore from the old versions also. So model registry will help you to keep a track of all this, because model registry is a model metadata. Plus finally deployment, how the deployment should happen. So since our trained model is already in the ready for the deployment, we will need to create a connection between the trained model, and also we need to see what happens if this particular mission will go down and my model predicted as yes, which means that your model is correct. And user defined functions are one of the solution for deploying ML models. So we will try to need to create this user defined function, and so that you can deploy your ML model as a inference by simply calling the function here. If you observe here, predict failure is my function. Inside that, sensor data we are passing, and this is going to find out for every row that is in the database. For every row in the sensor data will be tagged this particular like predicted failures. So we need to identify the different ways to deploy. Also, we have DevOps culture. We also will use like technically we may need to do so many things here to deploy the model. It can be even like deployed on a cloud also, Adobe, Azure or AWS cloud. So deployment you have to decide with the end user only. So let us try to see some example. Whatever you see here, this is also an example where this is a logistic regression model because I am loading from the snowflake.ml modeling and linear model. I am loading just a minute the session and then all the functions, and also we are loading the Snowpark types, what types available, and in Snowflake machine learning we are all loading all this logistic regression and then standard scalar and pipeline and other metrics. So till here you are going to load all the required libraries or packages. Once after your package got loaded, then we are just creating a session. So here I need to clearly mention my session parameters, right? Correct or not? So what are the current account details? Let me get. Use the same. So this particular function is going to create a session, Snowflake session to connect. And second function is to generate the synthetic data, the sample data. So 2000 records I am just adding here. So it will generate 2000 records. And then we also have the different operations we are doing here. Like since it's a manufacturing data, we are converting each column into a like a structured form. And here we are creating a data frame, HANA data frame using different columns which are available in the table. So here failure label is our outcome, and install whatever available will become the independent variables. And only failure label is the dependent variable. And this data frame we have to create, but before that we also need to configure the or map the structured type. So we are using the corresponding correct data types and assigning that. So schema is nothing but the column names and corresponding specific data types. So finally, you are returning a session here. So this is going to return a session, and it will create a data frame with this data directly, whatever we pass in here. So this is function we are going to execute now. Let us go here. So similar to yesterday, we will try to use the existing environment. So same like yesterday, let us try to create a final table here, which we did already. In index data bank, we have some particular banking CLV predictions is the final table which we created yesterday. Similar to that, for this logistic regression also we have to create a table. So let us try to do that. So where you are creating the final table, in the last we should create that my final predictions. Just give me a minute. Column name, target column. Let us run this. So this has to create some centric data. I also need to generate the algorithm. So it is running. If you observe here, 2000 records have been loaded, and a Snowpark ML pipeline is running. Let us see. So finally, there should be a predicted failure column should be there. So let us wait. Can you see that? Both of you?
Yeah.
See, this is the actual one and this is the predicted one. You can see here, the last two machines are not giving correctly. That may be because of the data may not be sufficient, but our accuracy score is 92%. You can see here. Hope you're following.
Okay. Yeah, we are following.
Yeah, this data frame only here, I'm just displaying the data frame only. You can see here. So how to create a table? Remember, there is a function, right?
Yeah, dot
Session dot
save.
save as table. The data frame dot save as table. So if you see here, finally we create a table here like this. Before closing the session, we would have ran this. Correct, right?
Correct.
So I'll give here as I just give this name. So I'll rerun this once again. So now a table should be also created finally. Correct, right?
Yes.
So as per this, my table should be created in which schema? In my connection details, whatever I gave here. In the same ingest data dev schema, I should see a table with name now. Manufactured CLV predictions is my final table. So training is completed. Now it is time to generate the results. So this is basically how you go and try to build a logistic regression to classify the man. See here, you can see here the mission ID, the tag queue, the toolware in minutes, and the failure label, and then what the mission predicted. So this is the actual status, and this is the predicted status. Now it has been changed. You can see that this time the data is changed now with the second execution. So I should see a table now. Let us go back and see here. Is there any table got created? See, there is a table here. Can you see that? Manufact. And this is the table with my manufacturing detail. The air temperature and process temperature, rotation speed, torque Q, tool wear in minutes, mission ID, and all you can see here. And finally, you can see here the actual one and the predicted one. So we have total 431 rows which got generated. And this can be connected by Power BI dashboard or any kind of dashboard tools, and we can build and see the status of all these machines and the root cause of the failure also. I hope that is clear, both of you.
Yeah.
Yeah,
So
it is clear.
yeah, we'll practice this today.
Yeah, we'll practice, but the data set we don't have, right?
This
Do
for
you
this
have the
no need
CSV
data
file?
set, right? It will generate in the code itself. See here
Okay. Can you
The,
show me the code one more time?
see here, it is generating the sample code also.
Ah, okay, okay, got it.
So no need to even create
Yeah, yeah,
any.
okay, okay.
This code, this function, the generate synthetic data. Even here also we have some synthetic data which are generating sensor data.
Got it.
You can
Okay.
change this. If you want more data, change this number. The number of rows
Okay.
you change to 5,000 or 10,000, whatever, and try to see. Here, Dev and Manoj.
Yeah,
Yeah,
it is
yeah.
clear.
Okay. So please practice and come back with your questions tomorrow. Okay.
Sure. Okay.
Okay.
Thank you.
Thank you. Yeah.